So now we are on question 8. So question number 8, it says study the circuit below, right? Then it says again, ignore the resistance. Ignore the resistance of the battery and the wires, right? Then switch S is initially closed. The battery transfers 3 times 10 to the power 4 joules of energy for every 2.5 times 10 to the power 3 charge, right, that flows through the circuit, right? So this is the circuit now. So V1, it goes now, right? Then from there it goes right A1, right? Then, so let me put this here and this one goes through somewhere there. So now this is A2. Now we are having A3, right? Then you're having a resistance of 4 ohms here, right? Right, then from A2, having V2, right? Then a resistance of 6 ohms there. Then they meet there, right? So switch S, which was initially closed, is that one. Right, then we go to the questions. So the questions 8.1. The questions 8.1 says determine the term EMF. Determine the term EMF, right? Determine the reading. Determine the reading on V1. Then 8.3, determine the reading on ammeter. Determine the reading on ammeter A1. If 3.24 charge, right, of charge flows, right through it, charge through it in 2 seconds, right? Then 8.4, if the reading on ammeter A2, if the reading on A2, the ammeter A2 is 0.65 amps, right? Determine the reading on A3. Determine the reading on A3, right? Then 8.5 says if the total resistance of the circuit is 7.4 ohms, right? Then determine the resistance. Determine the resistance of resistor R, right? Then now 8.6 we are saying switch S is now opened. Switch S is now opened. 8.6, what will be the reading? What will be the reading on voltmeter V2, right? If switch S is open, what will be the reading on voltmeter S, on the voltmeter V2, right? So now let's go to the questions. So question 8.1, we want to answer the questions. So from 8.1 is saying determine the term electromotive force, EMF, right? So 8.1 is concerned about the electromotive force, right? Which is total, it is the total work done. It is the total work done per unit charge. It is the total work done per unit charge. So EMF means the electromotive force, right? So let's write electromotive force. It is the total work done per unit charge. It is the total work done per unit charge, right? Determine the reading on V1. So let's first calculate the current that passes through. So we're going to say we are having a resistance of 4 ohms, right? So if we are having a resistance of 4 ohms, we are going to say current, the formula, let's start with the formula. It says equals to voltage over resistance. Current equals to voltage over resistance, right? That means we can now say the current on 3, right, equals to the voltage, which is 3.9 volts, over the resistance of 4 ohms, which will give us 0.975 amps, right? That will be the current passing through that, right? Then from there, V1, to determine now the voltage passing through V1, we can use the energy. So we can say 3 times 10 to the power 4 joules, right, times 2.5 times 10 to the power 3, which will give us 12 volts, right? It will give us 12 volts. Then determine 8.3, determine the reading on ammeter A1. Determine the reading on ammeter A1 if 3.24 C of charge flows through it. So I'm going to say I equals to Q over T, which will be equal to 3.24 divided by 2 seconds, right? If we divide that, we are going to get 1.62 amps, right? Then 8.4, Question 8.4. If the reading of the ammeter A2 is 0.65, determine the reading of the ammeter A3. So we can now say voltage equals to current times resistance. Voltage equals to current times resistance. So we're going to say V2 equals to 0.65, right? So let's say 0.65 times 6 ohms, which is the resistance. So we're going to get 3.9 volts, right? Then 8.5, from 8.5 we're given if the total resistance of the circuit is 7.4 ohms, determine the resistance of R, right? So our resistors, they are in parallel, so we have to identify that our resistors are in parallel. That's the first thing. That means we're going to say 1 over 6 plus 1 over 4, which will give us 5 over 12, right? From there we can now say 7.4 ohms equals to R plus 2.4, right? So R will give us 7.4 minus 2.4. So R will give us 5 ohms. That will be the resistance. Right, then what will be the reading on V2? So the reading on V2, so we're saying no current on V2, no current will pass through, V2 because there will be no reading, or the reading will be 0 on V2 because A2 is broken, right? Because A2 is broken. So that brings us to the end of the June 2025 Physical Science Grade 10 from the Limpopo Province.